Hello everyone. So I hope my voice is clear to all of you. What's wrong with this? Yes. Okay, that's great. Were you able to watch the recordings the for the algebra topic that we just recently covered? Never mind. Okay, that's great, 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 great. Okay, so let's wait for 1 or 2 minutes, and yeah. Okay. Okay. So the topic today that we have is called mensuration. Mensuration is extremely important as far as exam point of view is concerned. It is a part of your paper 1 and it is also a part of your paper 2, and it comprises of roughly um, 25 to 30 marks out of 200 in O levels or in IGCSE, especially in paper 4 in IGCSE. Right? Okay. So what do we study here in mensuration? Now, we know one thing for a fact, and that is that mensuration basically is an idea of, first things first, dealing with shapes, with different types of shapes. Now, that dealing can be done in various ways. What do we mean by that? For example, we might have to find area of a shape. We might have to find perimeter of a shape, right? Now, these are two basic examples, general examples. In other cases, we might have to find let's say, the circumference of a of circle. We should be eligible to understand the properties of a circle, because a circle is a shape that is quite different as compared to the rest of them. Properties of a circle. Okay. Okay. So whenever we're talking about area, we know one thing for a fact. Like, okay, um, let's say if I ask you what is the area of this squared, without telling me what the formula is, tell me, what do we mean? What do we mean by the area of a square? Yes. Oops. What was that? What was that? Wait, 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 wait. Well, yeah, never mind. I was just trying something extraordinary. I'm using paints because it's easy to me. And secondly, the topic today is mensuration, right? So, um, uh, you know, we need lots of shapes and all. So that's the reason, right? That was funny and quite unexpected. Okay, so whenever we're talking about an area of a square, we refer to the fact that what or to what extent does the shape hold an amount, hold an amount of a numerical magnitude with a unit. Now, what do I mean by that? For example, if the area of your house was, let's say, as an example, 40 centimeters squared, impossible, but generically speaking. And how many things does your house need? It needs, of course, furniture, it needs decorations, it needs drainage, many things, right? Now, if we were to decrease or perhaps utilize all of that space for these basic necessities, that space will be occupied, right? That space will be occupied. The presentation of that space can be shown by a numerical magnitude with a unit. For example, if 40 centimeters squared is the area of your house, right? So the furniture will be roughly 10 centimeters squared. The decorations could be somewhere around 15 centimeters squared, whatever, right? This is just a basic example. So this is what you have to know as far as area is concerned. Okay? Can I erase all of this? Okay. Okay. Now, when we are discussing area, unfortunately, according to your syllabus, you are expected to memorize the formulae, right? So there are a few shapes, but we can logically look at them as well. Okay, so it's not like really impossible to memorize the formulae. We can look at them through logic as well. Memorize formulae. But if we look at perimeter, there is no need to memorize. Rather, perimeter can be considered as the sum of all outer sides. Okay, let's have a look at this shape. What is this shape? Squared, right? Square. Okay. If I want to find the value of this, the value of the area of this squared, this will be considered as length. And although this can be considered width, but we know one thing for a fact, that in a square, all sides are equal. In a square, all sides are equal, right? So instead of me writing this as W, can I, for my own ease, can I just signify this as L for my own ease? Length. Now, the formula for the length or the area of a square is very simple. It's L squared, right? So if we were to have a square, and the what do you call it? Yes? No, no, it's not. It's not necessary. We'll study those cases later on. If the value of one side was 3, and if I was to find the area of that side, it's simply of that square is 3 squared, which becomes 9. As simple as that. No rocket science. Okay. If I wanted to find the perimeter of the square, if I was to find the perimeter of the square, what do I do? Instead of me writing the formula, you might have many marking schemes, not marking schemes, notes, which say that the formula for L for area is of a square is L squared, and the formula for the perimeter of a square is 4 times L. Now, okay, they're right. But if you have to memorize the formula for the perimeters as well, it doesn't make sense. Just simply add them all up. Yes, it is 4 times L, but why make your life so difficult memorizing formula? That becomes 12. Okay? Okay. Done? Great. Let's move forward. Write it down. Write the perimeter one down. We'll discuss one shape. We'll talk about its area, and we'll also talk about its perimeter simultaneously. Can Can I erase this as well? Have you all written it down? I hope you have. Okay. Then we have the rectangle. Okay. Now, generally speaking, this portion, the larger portion, is considered the length, and the portion which is representing the x-axis, the y-axis, sorry, represents the width. The formula for the area of a rectangle is simply length times width. Okay. No, so mensuration is not that easy. If I was to open one question of mensuration right now, you'd be confused. It's not that easy. This is just the start. This is the very basic that we've been studying since, I don't know, grade 3 maybe. Perimeter, no rocket science, right? Length times width. Oh, sorry, not times. Basically, it's going to be, yeah, plus width plus length plus width, right? So because all of these two values will also be accounted for it. Can I say 2 into L plus W? Yes, I can. Okay, done. Great. Were we able to complete algebra in one day? So how would we be able to complete mensuration in one day? It's a huge topic, and I think to me this was personally the most difficult topic that I had. Even when I was doing my IGCSE, it was the most difficult one. Okay, the next shape that we have is area of a triangle. No rocket science, I guess. Now I want to ask you all one thing. What's the formula for the area of a triangle? 1 over 2 multiplied by, oh no, AB sine C. AB sine C formula, we will study that later on, not now. Just leave it for now. Yes, that is a formula. 1 over 2 multiplied by A multiplied by B multiplied by sine of C, but just leave it for now. Yes, you are right. You're mathematically right. But still, just be relevant to what we're studying right now. Base times height. Good. Now be careful with height. Most of the students, they consider this portion as height. Okay? This is absolutely wrong. This portion is never height. This is the height of a triangle. This is what you call the slant height. Okay? This is the slant height. Okay? Done? Yeah, so basically two right angle triangles give you one complete triangle. I mean, this is also a triangle. Isn't this a triangle? This is also a triangle. Oops, what's this? Oh, looks like I cannot shift it to the other side. Well, that's fine. Wait, let me make a design. I mean, this is what architects do, so I can do that. some sort of list. Well, are you done writing, everyone? Great. See, this is the best part of using paints. Most of the people nowadays they don't. I used to use OneNote. It's just average, honestly. I'm not. I don't consider that any special. Okay. In some cases, you might have a triangle. You might have a triangle like this. Okay. But there will be a slant line emerging from one of the vertices of the triangle. Okay. This is a special type of a triangle that you people need to know. Okay. Any line that is in accordance to the x-axis, a line like this is considered baseline. If this is the baseline, I just want to make one change. Yeah, just make it a bit dotted, some sort of, so that you people don't confuse it. Okay, make a line like this. I would recommend you all to use pencils, not pens. Okay, the portion that you see here, wait, this portion, right? This is the base of a triangle in such a case, okay? And this will be considered as h, the height. I'll write height completely because some students might confuse that with hypotenuse. Okay, first things first, just write this down. Then I'll give you all a question. Okay, okay, if I am shading this portion of the triangle, yes, it looks like a painting, right? Quite fascinating. I mean, OneNote was honestly quite overrated. I just didn't enjoy those features, right? Okay, if I was to, can I erase this? Okay, okay. So here we have some sort of a triangle. The top vertex can be considered as C. The bottom right is A. This is, let's say, it's B. The vertical height is 3 centimeters, and one part of the base is 8 centimeters. I want you all to find me the area of the triangle ABC. Not very difficult, right? Only this portion. What does that become? 1 over 2 multiplied by base, in our case, which is 8, right? In our case only, and height, which is 3. That becomes 24 upon 2, which is 12. Okay. Now, Do we understand all of this? Are we understanding this? Good, good, good. Okay, let's move forward. This, you see, this lecture is going to be very boring. All of you all know all of this stuff, no rocket science. Okay, now let's move on to something new. A triangle, okay? It's still a triangle. The triangle that you see in front of you has three angles, okay, that all add up to give you 180, okay? First things first. But likewise, they have three different sides, right? Do they have sides? They definitely do. Sides are denoted when we're studying triangles. Sides are denoted as opposite to their corresponding angle. So if this is triangle, this is side A. This is angle A. This will be side A. If this is angle B, this will be side B. This is angle C. This will be side C. So angle is generically shown as the capital letter, and side is shown by small letters. Okay, first things first. Okay, now, now if I was to find the area of such a triangle, okay, but the condition was that, what was the condition where this sort of a question applies? Find area of triangle when now here comes the twist, when no pair of a correct base or height is given. This is where it gets a little bit messy. You see, this is where it baffles with minds, but there is always a method to do it. Okay, there is always a method to do it. What is the method? Let me erase this. The method is very simple. To find the area of such a shape when you do not have a pair of a correct base or height, the f- to right? Okay, listen up. It is 1 over 2 as it is. No, 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 no. Let me just do it like this. 1 over 2. Let me make 2 small. And then sine of such and such. Okay. Now this might seem a bit awkward. Like, okay, what am I drawing? Is this a drawing contest? Yes? No, it's not. It's simple. Now, if I wanted to find the value of the area of a triangle which does not have a correct pair of base or height which is given, I will use this formula. And as it was mentioned earlier on by Abdullah, A B sine capital C. What do I mean by that? So we know one thing. The formula is 1 over 2 times A times B. Oh, sorry, base times height, right? Base times height. Now, base and height are are sides, right? Both of them are sides. Am I right? Am I right? Yes. But now we do not have the exact values that we might need. Okay. So we will use A and B as the sides, but we will also multiply them by the sine of the third angle which is present. Sine of the third angle which is present. Okay, give me a minute, we'll continue in a minute. Okay, so what do I mean by this formula? You see, the sides of A and B are these two sides, and the side of this angle C is this one. So what we will use is, we'll use the values of two angles of the side that are corresponding to each other. That are corresponding to each other, right? I can, I can use that. For example, okay, let's solve a question like this, should we? Let's solve a question like this. First thing first, write all of this down. Give me a minute. कोई नहीं Okay, so let's have a question. For example, if we were given, wait. Just I have the facility, so why am I wasting my time? Huh, you see? Yes. Okay, we have a triangle like this. Let's take advantage of all of this. Yes, 42 is the value of this angle, 30 is the value of this angle, and you were given the sides 15 and 12. Now be careful with this question. What what will be the method of solving this question? How do we find the area of this triangle? Be careful. We need to have the corresponding angles and sides together. We have these two sides. No, we don't have to. Okay, think about it. Okay, we know one thing for a fact, na? We know one thing, that all the three sides of a triangle add up to 180. So can I write 180 equals 42 plus 30 plus angle of x? Yes, I can write that, right? Okay, so let's solve this question. 180 minus 42 minus 30 equals x. Tell me, what does that become? 108? Good. Now, yes, okay. So we have the value of this triangle, of this angle x, which we have it in the form of 108. Okay, so we have this angle and we have its two corresponding sides. What's stopping us from applying this formula? 102 multiplied by 15 multiplied by 12 multiplied by sine of 108. Quickly tell me what is going to be the answer. 85.6? Yes. 85 point. What answer do you get? 83.4. How's that possible? Oh, be careful. Your calculator might just be in the radian mode. The correct answer is 85.6. Okay. How do you shift to that? What calculator do you have? Is it this calculator FX 57? I know you might have a KCO calculator. ES plus, if this one. This is the one, right? Go to shift, then select mode, and then press 3. What do you get now? 60.22. How do you get 60.22? Oh, come on. Be careful. Be really careful. Okay, do we understand this concept as of yet? Okay, great. Now let's move to another shape. Okay, let's move on to another shape. There are two similar shapes that generally look similar, but they aren't. There are two unique shapes of their own. One is called, okay, I'm giving you all time. Think and tell me what these are called. Okay, the first one is called, oh, what the hell? Yes, the first one is called rhombus, good. And the second one is called a parallelogram. Okay, first one is called a rhombus, not this big. And the other one is called a parallelogram. It's supposed to be, yeah, now that's better. Okay, now, okay, so this is an example of a rhombus, and this is an example of a parallelogram. Okay, now these shapes do look like rectangle and squares, but they are a bit slanted versions of them. But we know one thing for a fact, that if we want to find area of any quadrilateral, what do we mean by a quadrilateral? Quadrilaterals are shapes that have four sides. They don't have to be equal, but opposites of them are equal, and most importantly, they are parallel. We know this one thing for a fact, right? Okay. So if we want to find the area of such a shape, we first must know what is the vertical height of that shape, whatever it is. These two are lines that show vertical height. This is called the diagonal length. Yes, this is an example of diagonal length. You see, shapes can be, no, 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 look, shapes can be divided into many examples. There's not just one or two examples that we might have of shapes. Shapes, unlimited examples, okay? Yeah, oh, without a doubt. Okay, have you all written this down? The formula for the area is, for both of them, is simple: base multiplied by the vertical height. As simple as that. Let's study one more shape and then we'll call it a day for today. Okay? Let's move forward. We won't be doing, of course, not in a single day. It cannot be done. Okay. Then the last shape that we have is the one which is very important to all of you as far as your, especially your kinematics is concerned in physics or in maths, both ways it goes. What do we call this shape? Yes? What do we call this shape? A trapezoid? Yep, a trapezoid or a trapezium. Trapezoid or a trapezium. In our syllabus, it is generally called as a trapezium. Okay? It's fine, you can call it any one of the two. This is one side, this is the other one. Okay? And then there is a vertical line between them. This vertical line represents the height. Okay? If we want to find the formula, if we want to know the formula for the area of a trapezium, is 1 over 2, as we know, it's a triangle, it's like a piece of a triangle. There are two ways of writing the formula of a trapezium. The general one is 1 over 2 multiplied by height multiplied by a plus b. A plus b are the two sides. Okay? This is the first method of finding the area of a trapezium. The second method, which you might be quite fond of when you'll be studying physics, it's also right, but I mean it can cost you more time. That is that you can divide this shape into three different shapes like this. Okay? Like this, you will divide the shape into three different parts. You can calculate the area of this part, 1 over 2 times this portion, whatever you have, let's consider that x, and the value of the height is going to remain constant. Once again, whatever value you might have, end up having here. And the area of this triangle can be given as height times x, or length times width, right? These are two ways. This is going to help you out in physics. So we're done with the first part of mensuration today. From tomorrow, we'll discuss more about circles. Okay? I mean, apart from today, most of the shapes that we looked at were 2D shapes. Okay? 2D shapes, two-dimensional. Then day after tomorrow, we might be studying 3D shapes. For example, we'll be looking at volumes of, we'll also mention volumes of cubes, cuboids, cylinders, and all of these shapes. Yeah, it's not a very easy topic, honestly.